All right, so this is check understanding number 2 from today's lesson. So I know the directions aren't here, but what the directions ask us to do is to simplify each of these expressions and state what values are excluded from the domain or make the expression undefined. So that's what we're going to be looking at doing in each of these problems. So to start with number 1, we're going to first factor the numerator and the denominator. So in our numerator, there's a GCF of a, so I'll factor out an a. A times a is a squared, a times negative 9 is negative 9a. Now, before I list all these factors of 36, one little shortcut that I'd like to just tell you about is if one of the factors down here, one of the binomial factors of this trinomial is not a minus 9, then this wouldn't be able to be simplified. So it's fairly unlikely that if they're asking us to simplify, if one of the binomials is an a minus 9, it doesn't simplify. It's not very likely. So I would actually start with that first, a minus 9, and determine if that would work. So if it's negative 9, then the other factor of 36 would be negative 4. Well, negative 9 plus negative 4 does have a sum of negative 13, so this does indeed factor as a minus 4 times a minus 9. If you don't see that, or if you forget that, that's fine. If you list all the factors of 36 and figure out which one has a sum of negative 13, you're going to get the same thing, but it is a little bit of a shortcut. If you get something like this here, try a minus 9 as one of the two factors down here, because if it isn't, then this won't be able to be simplified. Before we finish simplifying it, now is a perfect time to figure out what values of a we must exclude. So remember, if either of these factors equals 0, then the product of our denominator would equal 0 and the expression would be undefined. So what we need to do is what value of a makes this factor equal to 0, and what value of a makes this factor equal to 0. These are both pretty straightforward to figure out. We would add 4 to each side here. We get a equals 4. Therefore, 4 cannot be evaluated for this expression because it will make the expression undefined. And it also cannot equal, we get a equals 9, positive 9. So we figured out what values are excluded because they make the expression undefined. Now we just need to finish simplifying it. So a minus 9 over a minus 9 reduces to 1 over 1. All we're left with in our numerator is a over a minus 4, and even though, remember, we can't reduce these because a in the denominator is not a factor, it's a term, and since we're dividing here, a would in a numerator would need to be both divisible by a and the 4. Well, we can't reduce a over 4, so we're done. The last thing we just have to do is bring down a cannot equal 4 or 9. Okay, moving on to the next one. First thing I'm going to do to factor my numerator is find a GCF. So there's a GCF of 4x. If I factor out 4x, I'm left with x squared plus x minus 6. In my denominator, I have a GCF of 2, so I'll factor that out. I'm left with x squared minus 9x plus 14. So let's factor this trinomial. The factors of negative 6 that have a sum of 1 would be 3 and negative 2. 3 times negative 2 is negative 6. 3 plus negative 2 is positive 1. So the numerator is going to factor as 4x times x plus 3 times x minus 2. And just like we said, over here, it's likely that one of the binomial factors here is probably going to be either x plus 3 or x minus 2. It's fairly likely. So what factors of 14 have a sum of negative 9? Well, that would be negative 2 and negative 7. Negative 2 times negative 7 is positive 14, and they have a sum of negative 9. So our denominator is going to factor as 2 times x minus 2 times x minus 7. And again, before we finish simplifying this, let's figure out what values of x we have to exclude from the domain. So 2, there's no x here to evaluate for, so that can't equal 0. This factor, though, could. So if x was equal to 2, 2 minus 2 is 0, so I know that x cannot equal 2. And in this factor, if x was positive 7, 7 minus 7 is 0, and if this factor is 0, the whole product would be 0. So there we go. X cannot equal 2 or 7. Now we just need to finish simplifying this. So 4 halves reduces to 2 or 2 over 1. X plus 3, there is no x plus 3 factor down here, so that won't simplify. X minus 2 and x minus 2 will reduce to 1 over 1, and that's it. So our numerator, all we have left is 2x times x plus 3 over, in our denominator we have 1 times x minus 7, which is just going to be x minus 7. So there's our final answer. And I move this over a little bit closer, but there's our final answer simplified. All right, last one here. We want to rewrite this in standard form first before we try factoring it. So this negative n squared's got to go out front, plus 2n plus 24. Well, I don't want to try to factor with a negative coefficient or negative first term, so I'm going to factor out a negative 1. If I factor out a negative 1, I get n squared minus 2n minus 24 over our denominator. I'm going to just factor it right away here. Our denominator here is a difference of 2 squares, so n squared is a perfect square and 16 is a perfect square. So that's going to factor as n plus 4 times n minus 4. And again, just like we've said in these last two, it's likely that one of the factor pairs of this trinomial is going to be either an n plus 4 and an n minus 4. And if we figure this one out, we would actually end up finding the factors of negative 24 that have a sum of negative 2 would be negative 6 and positive 4. So negative 6 times 4 is negative 24. Negative 6 plus 4 is the negative 2. So our numerator factors as negative 1 times n minus 6 times n plus 4 over our denominator, which is n plus 4 times n minus 4. So what values of n are excluded here? Well, what value of n makes this factor 0? That would be negative 4. Negative 4 plus 4 is 0, so the product would be 0. And in this one, it would be positive 4. So n cannot equal negative 4 or 4. And now we just reduce any common factors, so n plus 4 over n plus 4 is just 1 over 1, and that's it. So we're left with negative, I could put the 1 there, I'm just going to leave it as negative n minus 6, there's an implied 1 there, over n minus 4, and n cannot equal negative 4 or positive 4. So there you go.